Okay, today we're going to talk about quadratic transformations. So what that means is how we can look at the equation of the linear parent function and use that equation to help us figure out how the vertex is moving and how the parabola is being transformed. At this time, we're not looking at it's horizontal stretches and compressions. Okay, we're really only looking at vertical stretches and compressions. So we're going to start off by kind of breaking down what all the pieces of the vertex form mean. Okay, so this is, I believe there's one more term that goes in vertex form. Yes, there, but it doesn't look like when you look at our star chart, our formula chart, we don't use that. So, yay, I guess. So let's start by talking about what all these different pieces mean, okay? So A tells us a couple of things, okay? So the first thing that A tells us is it tells us that if A is positive, it says that my parabola opens up. So that means it's going to be opening, it's going to be like that, okay? If A is negative, then my parabola opens down, which means it's pointing that way, okay? So that's one of the first things that A tells me. The second thing that A tells me, the absolute value of A. So if the absolute value of A is greater than 1, then I have a vertical stretch. So that means it's like I'm taking my parabola and I'm stretching it like this. So it's going to get narrower and taller. So like everything's going to get tall and skinny. Just like if you take a picture, take a photograph and you stretch it, like you don't stretch it on the corner, you stretch it like this. It's going to, if you stretch it out, everything gets real tall and real skinny looking. Okay, now if the absolute value of A is between 0 and 1, then we have a vertical compression. So like I'm taking it and I'm going like that. So it's going to get real short and real fat. Now, when we talk about absolute value, what we're talking about is how far away something is from 0 on the number line. Okay? So if I have a number line, I don't have any place to put it, but if I have a number line, if I say what is the absolute value of 7? Well, 7 is 7 hops away from the number line, from 0 on the number line. Negative 7 is also 7 hops away from 0 on the number line. So when I look at this, what this means is I don't care about the sign. I don't want to look at the sign, the integer sign on this number. Okay, so if it was negative 6, I would look at 6. 6 is a vertical stretch. If it was negative 0.5, I would look at 0.5. 0.5 is a vertical compression because 0.5 is between 0 and 1. Okay, so that's all the stuff that A tells me. Now, when I look down here, this x minus h squared part of my parabola, okay, this is the part where we have to remember that when we put our two parentheses together, they make an O, which stands for opposite. Okay, our two parentheses, they come together. They're side to side, so they're horizontal. They come together to make an O that means opposite. So whatever happens inside these parentheses is the opposite of what I think it is. Okay? So when I see a negative h, negative numbers go left on my number line. But since it's the opposite, what this really means is that my graph, well, I guess my vertex, let's be more specific. My vertex shifts right, okay? Not left, it shifts right. Because even though this looks like negatives go left on the number line, whatever's happening inside here is the opposite of what I expect, so it's actually going right. Likewise, if I see x plus h squared, that means my vertex is shifting left. Now, just to be clear, whatever you see here, h is actually the opposite of that. But if I see x minus something squared, it's a right shift. If I see x plus something squared, it's a left shift. Okay? The last one that we have to look at here is k. So when I see a positive k, Okay, that's an H. Okay, when I see a positive K, okay, positive K means that we are vertically shifted up K units. And technically this means I'm vertically shifted right H units, okay? If I see minus K, I'm vertically shifted down K units, okay? So when I see this, this tells me if I have a stretch or a compression vertically. It tells me if I have a vertical stretch or compression. If it's positive, it's pointing up. If it's negative, it's pointing down. This part here, this tells me which left or right how I'm shifting. Okay, so this is stretch, compress, and up, down. And then this is left, right, shift. This is up, down, shift. And this is up, down, open. Okay, so this tells me if I open up or down. It tells me if I'm stretching or compressing. This tells me if I'm shifting left or right. This tells me if I'm shifting up or down. And there is an F in that. Okay, shift. Okay, so let's try a couple of examples. Okay, so if I look at these quadratic transformations, one of the other things I want to point out is if you don't see, so like for example, you may see an equation, so you may not see an equation in this form. You may see like y equals 3x plus 5, okay? If you don't see parentheses, then it is all happening vertically. So if you see 3x plus 5 and no parentheses, then that means this is being vertically stretched by a factor of 3. This is being shifted up 5. Because there's no parentheses, there's no horizontal change happening, okay? Now let's look at this quadratic transformation. We're going to try two examples. And these are the same ones we did in class. So example 1. We have y equals 0.5, parentheses, x plus 1 squared minus 4. Okay, so we're going to start. The most important thing I think to start with, and I think this is important because it's just like in anything, like when we write down our m and b when we're looking at slope, because we want to know where those are. It's important for us to identify a, h, and k. Okay, we're going to identify A, H, and K because as we saw over here, they tell us everything that we need to know about what's happening to this parabola. Okay, so A is 0.5, and I'm going to put a plus next to it because even though I don't need to put that plus, I'm going to put it anyway because it's positive, which means it's pointing up, and I want to know about that. That's important. Okay, now for H, remember everything inside the parentheses is the opposite of what I expect to see. So this is positive 1 inside the parentheses. When I take it outside the parentheses, it's negative 1. Okay, that means H is negative 1. And that's what I was talking about here about x minus H. When you see x minus something, H isn't positive. H is the opposite of what you see in here. Okay, so whatever you see in here, it's the opposite. Now, this negative 4 is outside. So it's exactly what it looks like. So right now, I have a whole bunch of rich information. Okay, so first thing I know is I know the vertex. Okay, my vertex is h, comma, k, which means h is negative 1, k is negative 4. That's the coordinate of my vertex. Okay, the next thing I know is I know which direction my parabola opens up. It opens up because this is positive. So my parabola is going to look like this. If I were answering a multiple choice question, just knowing that that's positive would allow me to cross off any answer choices that had parabolas pointing down. Okay? We also know that we have something happening vertically here. We have either have a compression or a stretch. And since this is between 0 and 1, the absolute value of this number is between 0 and 1. It means I've got a vertical compression. Okay? I can also look, I also see here that I have shifting going on. And I can tell because I've got x plus a number, and I've got minus k. Well, x plus a number means I'm shifting left, and that number is 1, so I'm shifting left 1. And I have minus k, so I'm shifting down 4. Okay? I know all of these things about this parabola, so I know where the vertex is. I know that it's going to be opening up. I know that it is vertically compressed, so that means it's going to be fat and short, if that makes sense. It's not going to be any shorter, actually, but it's going to be fatter. So it's going to be, because I'm squishing it, it's going to get wide. Okay? So I can pick, it's going to help me pick the correct answer. Let's try another one. Okay? The next one, the other one is, let's see, example 2 is y equals -6 x minus 5 squared plus 2. Okay, so again, I'm going to identify the important stuff. Okay, A, H, K. Anytime I see something in vertex form, I'm going to identify these things. Okay, so A is -6. H is the opposite of what I see in there. I see -5. That means H is +5. K is +2. Okay, so again, immediately I can identify my vertex as H comma K, which makes it 5, 2. Okay, I can tell which way my parabola opens. Since this is negative, it's opening down, which means my parabola should look like that. Again, easy to help me eliminate answer choices. Now look at this. Now, I've had a lot of people today say this is a vertical compression because -6 is less than 0. But -6, I don't care about -6 because I already used the negative. I used the negative to tell me whether it was opening down. I'm looking just at the number, at the absolute value. So I'm looking at 6. And 6 is bigger than 1, which means I have a vertical stretch. Okay? And it would be by a factor of -6. And I'll talk to you in the next video about why that matters. Okay? I'm going to be shifted which way? This is negative in here, which means it looks like it's going to go that way, but that means it's going right 5. +2 means I'm going to and up 2. And this is just information that I pulled out of vertex form. Okay, so in the next video, I'm going to show you how to use what we know about symmetrical pairs and about the pattern of the parent function to actually graph anything we want to, anytime, without having to use our calculator, and to fill in a table whenever we want to without using our calculator.